Hello everyone, welcome back to DNA Bioscience. So today's topic is the hybrid dysgenesis in Drosophila, which is generally caused by the P elements. So there was a question regarding this topic. It is a part B question. So the question is the hybrid dysgenesis in Drosophila is caused by the P elements. Which one of the following crosses between different cytotypes will lead to the dysgenesis? So they have given four options. So let me first tell you what is the meaning of dysgenesis. Okay, here it is written hybrid dysgenesis. So dysgenesis generally means some kind of abnormality. Okay, it may be happen in some organ or it may be happen totally. It will change the phenotype. Okay, so the abnormality which is occurred due to the P elements in Drosophila, that is hybrid dysgenesis. So hybrid dysgenesis is the dysgenesis or the abnormality of embryo due to the hybridization between unrelated genomes. Okay. So what is P element? P element is a transposon. Transposon means it is jumping gene. It has the ability to transpose from one location to other. It is present in the Drosophila melanogaster and its main function is to change the phenotype after the hybridization. So it may lead to the sterility condition. So it is called the hybrid dysgenesis. That means the abnormality occur after the hybridization which leads to some kind of phenotypic changes. For example, sterility. So it is a type of transposon. It is generally class 2 transposon which operates through cut copy mechanism, and the P elements in Drosophila it produces an enzyme called the transposase. Okay, the activity of this protein is essential for the transposition process. As I shared, the P element, the function is it is a jumping gene. It can transpose from one location to other. Okay, so let's come to the process that is the hybrid dysgenesis in Drosophila. So generally what happens, it is the high rate of mutation in the germline cells. So there are two kinds of strains, that is one is P strain or P cytotype, that is called the autonomous P element, and one is which lacks the P element, that is called the M strain or the M cytotype. So the one is P strain and one is M strain. Okay. So the hybrid dysgenesis phenotype is affected by the transposition of the P elements within the germline of offspring of P strain males with M strain female. So generally the P strain is present in case of male. So what is happening in case of hybrid dysgenesis, the phenotype is affected by the transposition of P element. So in case of male the P element is present. So there is transposition of the P element to M strain. So the transposition occurs generally in the germline cells of offspring P strain males with M strain females. Why the transposition occurs only in the germline cell? Any idea? Because a splicing event needed to make the transposon mRNA, which is not occur in the somatic cell. Okay. So here the correct answer for this is the option B. Here you can see the P cytotype or the P strain is present in case of male, and the M cytotype, that is the M strain, is present in case of female. If if you are taking the option C, where the P cytotype is present in case of female and the M cytotype is present in case of male, in that case, the eggs of the P strain, here the eggs of the P strain, females contain high amount of the repressor protein. And because of that, it prevents the transcription of the transposase gene. I already said that the transposase enzyme is solely responsible for the transposition process. Okay, so when the P cytotype is present in female and it crossed with M cytotype, that is in case of male, the P strain female contain high amount of repressor protein. So what will happen? It generally prevents the transcription of the transposase gene. So ultimately what will happen? As a result, the hybrid dysgenesis does not occur in a cross with P strain female and M strain male. Okay. So you just need to remember two crosses. One is when the P strain is present in case of male and the M strain is present in case of female, which leads to hybrid dysgenesis and the phenotype completely changes. And the C option, if you are looking into the C option, in case of C option, here the P cytotype is, the P element is present in case of female. So as I said, the P type cell, P strain, in case of females, it contains high amount of repressor protein. So it will prevent the transcription of the transposase gene, which prevent the hybrid dysgenesis. Okay. So this is all about the hybrid dysgenesis in Drosophila, which is solely caused by the P elements, where the enzyme present is transposase, which is responsible for the transposition process. And in a cross between the P element carrying the female and M element with male, the derived cytoplasm, it represses the expression of the maternally inherited P element. Okay, so the resulting offspring show the wild type, that is the pure phenotype. Okay, but in a cross between the P element carrying the male and a M cytotype, repressors are absent in the maternally derived cytoplasm. Here, no repressors are present. Okay, so the two zygotes are chromosomally identical, but cytoplasmically it is different. So the P elements are activated and undergo the transpositions in the genome, causing the release of a mutator activity and a variety of dysgenesis phenotype in the offspring. So this is all about the P element mediated hybrid dysgenesis in Drosophila. I hope it makes sense to you. If you like this video, hit the like button and do subscribe, and don't forget to press the bell icon to get notified with the new video. Thank you.